Welcome back guys to our DSA challenge series. In this particular phase of the series, we are looking at the questions which are based on graphs. So let us see our today's question. This question says count the number of houses at a certain distance 1. Now let me read the question. We are given with three positive integers n, x and y. In a city, there exist houses numbered from 1 to n. N is already provided to us in the question. And these houses are connected by n streets. There is a street connecting the house numbered I with the house numbered I plus 1. So let me explain you the question in short. See, we are with the help of an example. The three values of n, x and y are provided to us. N is 3, x is 1 and y is 3 in this particular question. What does n means? N denotes the number of houses. Since n equals to 3, so it means there are three houses, 1, 2 and 3. Now in the question, it is mentioned that there is a street connecting the house numbered I with the house numbered I plus 1. So it means there is a street connecting 1 and 2, I and I plus 1. There is a street connecting 2 and 3. So these two streets are there. Now let me read the question forward. Numbered I and an additional street connects the house numbered X with the house numbered Y. So there are streets connecting I and I plus 1, that is 1 to 2, 2 to 3. Now there is an additional street connecting X to Y. So let me see the values of X and Y. In this particular example, the value of X and Y is given to us 1 and 3. So there is a street connecting 1 to 3. So I hope now the question is clear to you all. We are given with three values n, x and y, and denotes the number of houses, and there is always a street connecting the adjacent houses, means I2 I plus 1, like 1 to 2, 2 to 3 and so on. And there exists an additional street which connects x to y, and x and y values are already given. So this is the basic question. Now what we need to find? We need to return a one based index array result where result at the index of k represents the total number of pair of houses such that the minimum streets required to reach one house from the other is k. Suppose see, what all pairs can exist? There can be a pair 1, 2, there can be a pair 2, 1, there can be a pair 1, 3, there can be a pair 3, 1, and there can be a pair 2, 3 and a pair 3, 2. So these six pair exist in this particular example. Now, what are the minimum number of streets that we should take in order to reach from 1 to 2? It's a single street. Similarly, from 2 to 1, also a single street. So, result at the index of k. It means at first position, we need to return number of pairs such that the minimum distance required is only 1. In this particular question, if we want to reach from 1 to 2 or 1 to 3 or from any pair, the distance will always be 1. So the number of pairs for which the distance is 1 are 6. Number of pairs for which the distance is 2 is 0. And number of pairs for which the distance is 3 is also 0. So we will return 6, 0, 0. Let us see one more example. We were given n, x and y. N denotes the number of houses. So 5, n value is 5. So there are 5 houses. There is always a street connecting I to I plus 1. So 1 to 2, 2 to 3, 3 to 4, 4 to 5. There is an additional street connecting x to y. The value of x is 2, the value of y is 4. So there is a street connecting y to x to y. So this is the diagram which it looks like. Now there can be many number of pairs. 1, 2, 2, 1, 1, 3, 3, 1, 1, 4, 4, 1, 1, 5, 5, 1, and so on and so forth, which are numbered here. Now, what is the distance that we need to take in order to reach 1 to 2? The distance is 1. In order to reach 2 to 3, the distance is 1. So how many pairs are there for which the distance is 1? We need to return at index 0, at our result at the index of 0. For which the distance is 2, we need to return result at the index of 1, denotes the number of pairs for which the distance is 2. For number of pairs for which the distance is 3 is denoted by result at the index of 2. So we need to return this result. So I hope the question is clear to you all now. Now we will understand the approach of this particular question with the help of code. So let us look at the code. We have solved this problem with the help of Floyd-Warshall algorithm. If you have studied graph, then you would be aware of this particular algorithm. Then, first of all, what we did, we decremented the value of x and y. Why we decremented the value of x and y? We have decremented the value so that we can adjust our indices in zero base, because our array starts from zero indexing, right? So that's why we have decremented the values of x and y. After that, we have made a distance matrix. Initially, we have initialized this distance matrix with 10 raised to the power 9. That is a very big value. That's a very big value. Initially, we have initialized it. We usually initialize it with int max, but here the constraints are there. So that is why we have initialized it with 10 raised to the power 9. Now we have updated for int I equals to 0, I less than n, I plus plus. Distance at the index of I equals to 0. If I want to reach from 1 to 1, so distance required is 0. From 2 to 2, the distance is 0. So that is why we have updated distance at the index of I, and I will be 0. If I is less than n minus 1. Now, in the question, it is clearly mentioned there are streets connecting I to I plus 1. So there is a single street which connects 1 to 2. So if distance at the index of I plus 1 will be equals to 1, because there is a street connecting them, and distance at the index of I plus 1 I will also be 1. So that is why we have updated these values as well. Now, the special case which exists, that there is a street connecting x to y. So if we want to go from x to y, we only require one street. So that is why distance xy equals to 1, distance yx is also equals to 1. So in this way, we have initialized our distance matrix. Now we have applied Floyd-Warshall algorithm. What does the Floyd-Warshall algorithm do? This algorithm will update the matrix with the minimum number of streets which are required to reach 1 to 5, 1 to 7, or whatever the matrix domains are. So in Floyd-Warshall algorithm, we require 3 loops for int k equals to 0, k less than n, k plus plus I, and j. We will see if distance at the index of ik plus distance at the index of kj is less than distance ij, then we will update its value. Now, after Floyd-Warshall algorithm, we will have the minimum distances in our matrix. Now we will count the distance and we will update it in our answer. If distance ij is less than n, then we will update it. Now, why we are doing it plus 2? Because if the pairs 1, 2 is also a pair, 2, 1 is also a pair. And the distance which is taken by 1, 2, and the distance which is taken to reach from 1 to 2, and the distance which is required to reach from 2 to 1 are same. So that is why we have updated the answer distance ij minus 1 equals to plus 2. And then we will return the answer, which is our final end. So I hope the question is clear to you all. If the question is clear, don't forget to subscribe to our channel and as well as share it with your friends. Thank you.